Let's take a look at triangles. Triangles can be classified by the measures of their side or the measures of their angles. For sides, if they have 3 different side lengths, that is called scalene. If 2 of the side lengths are the same, that would be isosceles. So I'm going to say 2 congruent sides. And equilateral would be all 3 sides are congruent. Equa meaning equal, lateral meaning sides, so equal sides. If you're looking at the angles, if all angles are acute, which means all angles measure less than 90 degrees, the triangle is classified as acute. So all angles less than 90 degrees. An obtuse triangle has one obtuse angle, so one angle larger than 90 degrees, and then it has 2 acute angles. Right triangle has one right angle, or one 90-degree angle, and then 2 acute angles. Little information about isosceles triangles. So there is something called the isosceles triangle theorem, and then there is the converse of the isosceles triangle theorem. So the isosceles triangle theorem says that if you have 2 sides of your triangle that are congruent, then the angles opposite those congruent legs are going to be congruent. So in this picture, we know that side AB is congruent to side CB. That would mean that angle A is congruent to angle C. The converse of the isosceles triangle theorem states the opposite. If you know you have those 2 angles congruent, and those are called base angles, if A and C are congruent, then we know the legs or the sides opposite those angles will be congruent. So if A is congruent to C, then we know that side AB is congruent to side CB. So looking at the picture down below, it says name 2 unmarked congruent angles and 2 unmarked congruent segments. So we know that segment AB is congruent to segment AC. So that means that that triangle ABC is isosceles, and if those legs or sides are congruent, then the angles opposite them would be congruent. So that would be angle B, and we can't call it angle C because there is more than one angle coming from it, so we'll call that ACB. So we know that angle ABC is congruent to angle ACB, those 2 base angles. And on the other one, it says name 2 unmarked congruent segments. So if we look at triangle ACD, we can see that angle ACD and angle ADC are congruent. So that means the sides opposite those angles will also be congruent. So that would be side AC and side AD. With equilateral triangles, it will only be equilateral if all of the sides are the same and all of the angles are the same. So equilateral means equal sides, and equiangular means equal angle measures. So you can see in this picture that all 3 angles, angle A, B, C, are all congruent based on their mark. And then likewise, the sides are also marked congruent, so side AB, side BC, and side AC. Because the sum of the measures of the angles in a triangle is 180 degrees, If all three angles are congruent, that's going to make every measure 60 degrees. All right, so looking at the triangle inequality theorem, it states that the sum of any two sides of a triangle must be greater than the length of the third side. Otherwise, the triangle could not exist. So no matter which two sides I add, whether I add A and B together must be larger than C. If I add A and C together, they must be larger or longer than B. And if I add side B and C together, they must be longer than side A. For these examples, we're trying to determine if the side lengths could form a triangle. So you don't have to add all the different combinations. All you have to do is test the combination of the shortest legs. So for example 1, the two shortest legs are 8 and 17. And so if we add those, what we're trying to figure out is that greater than 24? 8 plus 17 is 25, which is greater than 24. So yes, this would form a triangle. For number 2, our two shortest legs are 3 and 3. Is that greater than 7? Well, 3 plus 3 is 6. 6 is not greater than 7, so this would not form a triangle. Think about if I gave you 3 pieces of spaghetti, 2 were 3 inches and 1 was 7 inches. No matter how you arrange those pieces, you could not form a triangle with them because the 3 and the 3 aren't long enough to meet up. So for number 3, our two shortest legs are 28 and 22. And if I add those, that is going to give me 50. 50 is not greater than 50, so this would not form a triangle. And finally, for example 4, our two shortest legs are 7 and 35, which together gives us 42. 42 is greater than 41, so this would form a triangle. All right, in these examples, we are looking at two given side lengths and we're trying to find the range of possibilities for that third side. So what we're going to do is we're going to use an inequality and we're going to take the two side lengths and we're going to take the bigger one and we're going to subtract the smaller one. So 22 minus 14. Okay. And then we're going to use the less than symbol, x, and then less than, and then we're going to add the two side lengths. Okay, so on the left side, when you're doing 22 and 14, you're assuming that those are the biggest or the longest legs of the triangle, and 22 minus 14 is 8. On the right side, we're assuming that those are the two shortest legs of the triangle, and so 14 plus 22 is 36. So what that means is our missing side has to be anything between 8 and 36. So 8 could be it's got to be greater than 8, so it couldn't actually equal 8, so 8.1 would be fine, and same thing is it's got to be up to 36. Anything in that range will form a triangle, and anything 8 or lower would not form a triangle, and anything 36 or higher would also not form a triangle. So let's try the same thing with example 6, but here we're looking at 31 and 28. So we're going to start by subtracting them. That would be if those two were the longest ones. So that would be 3 is less than x, which is less than, and then we're going to add them, assuming them that they're the two shortest. So we have 28 and 31, which is going to be 59. So our third leg could fall anywhere between 3 and 59, not including 3 or 59. It's got to be bigger than 3 or smaller than 59. On question 7 and 8, we're doing a similar idea, except for we're checking all of the possible side lengths for that third side. So we need to find the range first, and then we can choose what numbers fall within that range. So for number 8, we've got 27 minus 15. That would be the shortest. And then the longest would be 15 plus 27. So 27 minus 15 is 12. And then 15 plus 27 is 42. So our third length can fall anywhere between 27 and 42. So I know it says to check them. I think I'm going to highlight them just because it'll be easier on this screen. So 34 definitely falls within that range. 12 does not. So 12 is not a possibility. 29 falls within 12 to 42. 18 also falls within 12 to 42, and 43 does not. So we have 3 different possible lengths that would work for a third side of this given triangle. All right, same thing for number 8. Here we have 45 minus 9 as our smallest possibility. And our largest possibility would be 9 plus 45. So 45 minus 9 is 36. That's going to be our lower boundary. And 9 plus 45 is 54. That's going to be our upper boundary. Again, it cannot equal 36 or 54. It's got to be greater than 36, but smaller than 54. So looking at your options, 35 does not fall within that range. 58 does not fall within that range. So those are not options. 47 does fall within that range. 54 does not fall within that range. And 39 does fall within that range. So 39 and 47 centimeters would be viable third lengths. The last thing we're going to look at is how to order the sides and the angles of a triangle. When you know the side lengths, the angles can be put in order by comparing their sides. So when you look at the side length, so for this triangle, the smallest side in this particular triangle is BC, which is 7 feet. The angle opposite the shortest side will be the smallest angle. So if I'm looking for which one is opposite that, that would be angle A, would be our smallest angle. So the smallest angle is always opposite the shortest side. So in this case, that would be angle A. The largest angle is always opposite the longest side. So if we're looking at our picture, our longest side is 13. And so that means B, which is opposite, would be our largest angle. In our medium side, which is 10 in this picture, AB, opposite that is angle C, that would be the medium angle. So again, angle A is the smallest angle because it's opposite the shortest side, which is 7 feet. Angle C is the medium angle because it is opposite the medium side length, which is 10 feet. And then angle B would be the largest angle because it's opposite the longest side, AC, of 13 feet. So now we can do the opposite. We can order the sides of a triangle based on the angle measures. So the shortest side will be opposite our smallest angle. And then our longest side will be opposite the largest angle. And so if we're looking at this picture, order the sides from least to greatest. Let's take a look for our smallest angle. Our smallest angle is 37 degrees. And across from 37 degrees is side BC. So that is going to be our shortest side. Now let's look for our medium angle. Our medium angle is angle C, which is 54 degrees. and opposite 54 degrees is side AB. Finally, our largest angle is angle B, which is 89 degrees, and opposite that is side AC.